So we got more trig tonight?
Actually, I don't. I finished all my homework in class today, and I was wondering if we could do SAT, because I have that coming up soon.
Okay.
So.
When is that coming up?
In March, like the 6th of March or something.
Okay, that is pretty quick. Yeah, let's see if I can...
Yeah, it's coming up. And then, I mean, I can take it more than once, but...
I got us as getting through this problem, but, oh gosh. Is that up to date? That might be up to date. We've done a couple sessions non-SAT. So let me go to page 290.
Yeah.
Tell me if you recognize. I seem to remember doing number 5 with you. My notes are not consistent because it says we got through number 20. So let's see if, let me go a page or two ahead. I don't remember doing these. Do any of these look familiar? We definitely did not do that one there. So we haven't gotten through 20, which means we probably are still on this page. Let's start on 5.
Okay.
So first of all, what do we need for the product to be even?
2 odd numbers or 2 even numbers?
Actually, we need an odd times an even.
Oh, because you're adding.
Or
Sorry.
an even times an even. Both of those produce evens. Okay. So what's the probability of getting an even?
You have a 3 and 1/2 chance.
A 1/2 chance. Okay.
Yeah.
And since the other two are everything else, then the product has to be 1/2. Hold it.
Wait, would it be a half?
Well,
like 1/4? Wait.
Okay, let's do this the hard way. Okay, the hard way being the chances of an odd are 1/2 times an even 1/2. So that would be 1/4, but I got plus that. Well, that's a half times a half, another 1/4. A 1/4 plus a 1/4 equals a half. Now notice I took a bit of a shortcut when I did it the first time. I found the probability of this was a half, and either odd or even works for the second spin, which is 100% of the time you're going to get an odd or an even.
Mm-hmm.
So I just took the 1/2 times 1 to come up with my final answer. But this is probably the better way to do it here, where you break it down. This would cover more situations.
Okay.
All right, let's go to 293. Which of the following shows a relationship in which A is inversely proportional to B?
So inverse would be...
So give me the general equation. If I say A is inversely proportional to B, what should I write on the other side?
that where, like, wait, what do you mean? Like, that
That's
you
what,
want over?
that's what the inverse proportion means. It means A is equal to some constant that we don't know yet, divided by B. Okay? As opposed, this is inverse. This is directly proportional, where A would be equal to K times B. Okay? In an inverse relationship, when one number goes up, the other goes down. In other words, if I increase B, I'm going to decrease A. And if I decrease B, I'm going to increase A. So we're clearly looking for something that is like that. Okay, does A work?
Yeah, because A
No,
increases.
in other words, when I increase A, here B is increasing. In other words, A went from 1 to 2 and B went from 6 to 7. So that does not follow the inverse type relationship. We need B to be going down as A goes up.
Okay.
Okay? So this has promise, but K has to be the same. So if this were our answer, then A1 is equal to K over 9, so K would be equal to 9. Now, does that fit for the second row of the table? In other words, is 2 equal to 9 over 4? And the answer is no, it isn't. So this is also not inverse proportion. They're going in the right directions. As A is going up, B is going down, but they got to be going in the right amounts also, precisely the right amounts. And you figure out the right amount by figuring out what K is. Okay? So let's look at C. A is going up, B is going up. We can cross that off. Let's look at D. A is going up, B is going down. That has promise. Let's figure out what K is and see if K is the same on all three rows. Well, how do I figure out K?
Plug in A and B. And
So 10 equals K over 3, so K equals 30. Now, is that the same thing? Is 20 equal to 30 over 1.5?
I think so.
Yeah, it is.
Yeah.
And 30 is equal to 30 divided by 1. So D, not only are they going in the right direction, but by the exact right amount each time. In other words, without knowing about K, you couldn't distinguish between B and D. And if you didn't know how to figure out K, you would guess either B or D here. If you merely knew the fact that inverse means when one goes up, the other one goes down, and vice versa. Only B and D do that. But to figure out which one is actually an inverse, notice that the product is the same. 3 times 10 is 30, 1.5 times 20 is 30, and 1 times 30 is 30. So that's kind of a quick and dirty method way of doing it. Whereas up here, 9 times 1 does not equal 4 times 2, which does not equal 1 times 3.
Yeah. It's like quicker.
Yeah, the problem is it's also easier to get confused if you attempt that, because if they give you a direct relationship, then that no longer holds.
Okay. Ooh. Tricky. So
What's the sign going to be?
negative, so it would have to be V or W.
Okay. Now let's try to approximate some amounts. What is point A approximately?
Like 1 and a 4.
Okay. Minus 1.4. And what is B approximately?
Like a 4 again. Maybe a little less.
There's half.
Like a,
I would say 0.2. Closer to 0.2. Maybe 0.3. I don't think we're going to have to worry about it. We multiply both of those together. We get minus 2.8. What letter is it? V or W?
V.
Okay. Like I said, we didn't have to be very close to the real number. That actually looks like about minus 2.2, which means this was probably minus 1.3, and this was probably 0.15 or something like that. In any problem like this, where you're approximating the value, you know that they're not going to give you two answers close together, because everybody's approximation of these things is going to be different.
Okay.
All right. These problems I always found difficult, but there is a way that you can always be guaranteed of getting them.
Should we make an equation? Or do you have to?
What's their profit on every carton of orange juice sold?
2,000?
No, on every carton.
On every carton.
If you buy it for K dollars and you sell it for 4/3 K, what profit do you make?
4/3 of the price?
1/3 K.
1/3 K.
In other words, we have 4/3 K. That's the sales price minus the cost, which is K. That's equal to 1/3 K.
Oh, okay.
Okay. So 1/3 K is what we make on every one. 1/3 K times something, the number that we sell, the number of cartons, we'll call that Z, has to equal $2,000.
Mm-hmm.
And the question is, what is Z going to be in terms of K? Algebra?
Yeah, like 6,000 over K.
Right there.
Right?
Now, let me show you another way to do this, because I think this is important. This is a perfect question for picking numbers. And the reason it is because there's variables in the question and there's variables in the answer, which means K can be anything I want it to be. Okay? So let's make K, what's a good thing to make K? Not $1. How about $3? I'm going to make K equal $3, which means I sell it for $4. I buy it for $3. You see how I'm getting 4?
Mm-hmm.
Okay. So how many cartons would I have to sell to make $2,000? Just based on that. Buying it for $3, selling it for $4.
2,000.
Okay, so we know the answer is 2,000. So now find out which answer equals 2,000 when you let K equal 3. It's not A. B works. It's not C. It's not D, and it's not E. So whether we could do it mathematically or not, as long as I pick some number for K that allows me to figure out easily that, then I can pick numbers. You know, if I say this frequently, but if my life depended on this question, I would do it this way. I would not do it 1/3 K times some Z equals 2,000. That's the correct way to do it. But if my life depended on it, I'm going to make sure that using real numbers works. Now, in a problem like this where there's only one variable, it's not that hard to do the easier way. But when you get a problem like this where there's like 3 variables and there's multiplication and division going on, it's really hard to figure out which one represents the answer. But if you pick numbers, you can always figure it out.
Okay.
Of course, it's a time thing. If you're absolutely certain of the first method, then you don't need to go back and pick numbers. But if you have no idea how to do the problem, then usually the way to do it is to pick numbers. Almost always.
I read somewhere, because I was like studying for the SAT over this weekend, that you're not supposed to pick 1, but also it was one of those.
Yeah, you don't want to pick 1 and 0. The biggest reason you don't want to pick 1 is because 1 divided by 1 is the same as 1 multiplied by 1. So if you happen to pick 1, you may not be able to distinguish between multiplication and division. It's funny, I once told a student that, not to pick 1 or 0 when you're picking numbers. And we worked for 3 more years. And he insisted upon picking 1 and 0 every single time we had a problem like that. And it was never harmful to him. It worked every single time. But there are some problems where you don't want to pick 1 and 0. Notice the problem here if I pick a K of 1. If I pick a cost of $1, then I got to sell it for $1.33. That's 4/3 times 1. Now to make $2,000 in profit, that's not the easiest math to do. I'm only making a 33-cent profit each time. Well, okay, if I make a 33-cent profit, then I'm going to have to do 6,000 cartons. So it works, but the arithmetic is harder. It's harder to divide 2,000 by 0.33 than it was to divide 2,000 by 1. In other words, when I picked a K of $3, it made the sale price $4, the profit exactly $1. Very easy to figure out how many cartons we're going to need to figure it out. The beauty of picking numbers is you can usually figure out the answer if you pick the numbers conveniently. So picking numbers is not always easier way to do it. It's the guaranteed way to get the answer, but you kind of have to be careful about the numbers you pick. There's an art to picking these numbers.
Good to know.
All right, these are the grid problems. Have we done those before?
Nope.
They actually tend to be a little easier because they're not multiple choice. So I got 4C plus 3D equals 37, and D equals C plus 3. Well, what's the value of C? How are we going to do it?
You could find...
System of two equations. Notice that that's what we're looking at. That's one equation, there's a second equation. We're only two variables. How do we solve a system of two equations?
So you would solve one of them, you solve the left one to equal d, and then you set them equal to each other, and then you... Right?
Or the two methods that are most common are substitution or elimination. Okay? Substitution works really well when you have one of the equations fully defined for one of the variables. Because now I can just go back to this first equation and substitute c plus 3 wherever I see d. Okay, so I'm going to have 4c plus 3 times c plus 3 instead of d equals 37. Well, now I got one equation, one unknown. I've narrowed it down from two equations and two unknowns to one equation and one unknown. So let's solve this.
So, oh my goodness, so you would distribute the 3 out first, right?
Okay, so we got 4c plus 3c plus 9 equals 37.
Then you have 7c plus 9 equals 37.
7c equals 28.
And then divide c equals 4.
Okay. Now, a note about gridding. You can answer in whole numbers by just a 4. That would be perfectly fine. You can put it anywhere. You can answer in decimals. You can answer, if that's your answer, you can answer that way. You cannot answer in proper fractions. If my answer is 4.5, I have to answer that as 9/2.
Why? Is this math thing? SAT thing?
Yeah, it's an SAT thing here. Let's see if I even have the page. I don't think I have the page that it shows the instructions for gridding. When you take the test, the page before this page gives you a complete explanation as to how to grid your answers. And it does warn you against gridding with a proper fraction as an answer. This is the only one you have to be careful with, is a proper fraction. Number 10.
So you multiply that by 0.25 and then add it?
Okay, that's 2 steps. Is there a one-step solution?
Do we have to multiply it by, oh my gosh, by
1.25. Exactly. That's the same thing. In other words, if I multiply it by 0.25 and then add that amount to 500, it's the same as multiplying 500 by 1.25. And notice, if I'm doing this manually, this is the way I'm doing it. I'm doing it on a calculator. It doesn't matter which way I do it.
Okay. Do they let you use a calculator for this part?
Yes, they do.
Okay.
Okay. So it doesn't matter. But you see why I do it, the 500 on the bottom? Because I only have one row. Add the 2 zeros, put in the 2 decimal points, there's the answer. If I put the 1.25 down there and the 500 up there, I've got a row, and another row that I got to add all together. So whenever you're multiplying two numbers manually, always put the one with the fewest digits on bottom, fewest whole numbers.
Okay. Measure angle on inside a GL and play for the puzzle.
Let's draw a picture here.
Yeah.
What they're basically talking about is similar triangles. Okay. We got this triangle here. 6, 8. What's this measurement? What's the hypotenuse?
Oh god, is this a special rates?
Uh-huh. So 3, 4, 5.
3, 4. Oh yeah, so it would be 10.
Uh-huh. Okay.
Yeah. Wow. So bad at finding those.
We have another triangle where it says each angle has the same measure. That makes it similar. We'll draw it bigger. And we know the area of this triangle is 120. Well, first of all, what's the area of this triangle over here?
24. Because it's yeah.
So it's a fifth of the area of this triangle.
Okay.
What is one possible area? I misread this. If one side of this triangle is 120, what is one possible area? Well, which side should I make 120? Probably not this side here. Because does 8 go into 120 evenly? I don't know. But I know 6 does, and I know 10 does. So I have a choice.
Oh, okay.
I can make that 120, or I could make this 120. Well, that's pretty easy to make 120. That's exactly 12 times bigger than this. So what would this side be?
This side would be 6 times 12, so 72.
And this side would be
8 times 12, so 74.
96, 8 times 12?
Yeah.
Okay, so now figure out the area of that triangle. In other words, now I know that that triangle is similar to this triangle. So I really didn't need this area here of 24. That was a wasted step. The real key is picking one of these sides and making it 120 and making it a integer multiple of its corresponding side. Now, of course, you have to figure out the area of that.
3,456.
And you don't, I guess you can use commas or not when you grid. You don't need them. In other words, you could enter this 2 different ways. In 5 spots or 4 spots. Now, there are other answers. In other words, if I made the 120 this side, then everything is 20 times. So this would be 200, which I don't even need that side, but this would be 160. The math's actually a little easier to do that because it's 80 times 120.
Okay.
So there's another possible area. Now, I think your grid only has 5 spots in it.
And it doesn't matter which one you'd answer, right?
Right. Notice it says one possible area. So there's different possible answers. The only difference would be if one answer gave us a 6-digit number and the other one gave us a 5-digit number, we'd want to use the 5-digit number because the grid only has space for 5 numbers.
Okay.
You can't answer a 6-digit grid.
So if you get a 6-digit answer, you know you have to solve for another one?
Right.
Okay.
Yes. In this particular problem, if making this side the 120, the smallest side, which is going to give us the biggest area, is still 5 digits, but if that were 6 digits, we wouldn't be able to use that answer.
Okay.
All right.
Tricky.
Yeah. Now I will update my notes. We're on page 295 through question 11. Let me make sure I do that. So we'll know exactly where we left off last time. And today is 2/24.
Oh, it's been almost a month.
Perfect. Sarah, I will talk to you next time.
Sounds good.
Bye-bye.